Hello everyone, my name is James, and welcome to a recording of the first section of my CAD for FRC intro series for Team 4255, the Robodors. I would have liked to do a lot more of these live, but with summer schedules it seems like it's hard to find a time that everybody's available for, and that's fine. I do think there's a lot of benefit to doing it live, in that I can give you guys live feedback and hopefully help you avoid and work through some of the mistakes that I made when I was learning to CAD. It would have been nice to have someone over my shoulder looking at my work and helping revise things as I go, but I'm fine doing it asynchronously too. So let me know what you guys think of these recordings, and whether or not we could maybe find a time that works for everybody to meet live. So to get started, the first thing that everyone's going to need to do, if you haven't done it already, I know I sent out the instructions for how to do this via email, so some of you may have already done this, but if you haven't, go to onshape.com, that's the software that we use for CAD, /en/education in your browser, and well, I can basically demonstrate how to do this. And then you're going to press sign up. It's going to ask you to enter your first name and everything. Select that you're a student. Select that you're in grade school, K through 12. Check the box. I don't think it'll let me do it because I already have an account, but after that, yeah, it'll ask you for your school name. Put Monterey High School, put our website, put our city, state, country, put your graduation year, and then when it asks you what are you using Onshape for, put First Robotics Competition Team 4255 or FRC 4255 as your response to the prompt. Check all the boxes, and then it'll ask you to activate your email, and then it may actually ask you for like a student ID or something. I don't know if they still do that, but either way, you should be able to get an education account provided you're a student at Monterey High School. So that'll be free for all of us as students. So, moving on, you can go ahead and pause the video here and finish doing that process. And once you've done that, send me over email or Discord the email that you use to register your account. That's very important. That's so that I can add you to our team drive on Onshape. And once you're in that, you can view all of our files and also create files that I can view. And that's where we do all of our work, so it's really important that we do that. So, again, once you're done with that process, unpause the video and we'll get started. So the first concept that I consider like fundamental to CAD, every project that you start working on, every part that you start designing for each project, starts with sketching and sketches. So in most CAD software, Onshape included, a sketch is a workspace on a two-dimensional plane, and you use these geometric constraints and shapes to create two-dimensional features, which then are given depth to create three-dimensional features. So as you can see on the top row of images here, you have an example. You have a sketch where you just lay out the shape of your rectangle, and maybe there's a circle in the middle, and then you use the extrude tool, which I'll get to later, to add depth to the part, and then you modify that part in various ways using various tools to get your finished model. So these three-dimensional features are all derived from the two-dimensional sketch that you start with, and that is true for every single part that you design in CAD. So it all starts with a variety of sketches on different planes. So you might have a sketch on the top plane, you might have a sketch on the right plane, and together it creates this part. So to start a sketch, and I'll demonstrate some of this, you left click on a plane, and then you can or you can select the sketch button first. It doesn't really matter what order you do things in, but you can either select the sketch button, press Shift S, and then once you've done that, left click on a plane. So that normally will be one of the origin planes. There's a front plane, a right plane, and a top plane. And I will switch over to software real quick just to show you guys. So here's my CAD software, here's Onshape. This is the right plane, it has a little right on the top left corner, front plane, and top plane. These are planes. You can create other planes later, but they're basically just two-dimensional flat surfaces. So to create a sketch, you can either hit this button up here, or press Shift-S, and then it will ask you to select a plane, so for example the top plane, and now you've created a sketch. So after that, you're going to want to orient yourself so that your sketch is aligned with your view. So there's an easy way to do that. You can either right-click and select Orient View Normal to Sketch Plane, or just click N. So to demonstrate that, you can right-click and then press View Normal to Sketch Plane, and that'll orient me normal to the sketch plane, just like that. Or, if I don't want to do that, I can just press N, and it does it for me. So, super easy way to get yourself aligned with the plane that you're going to be sketching on. So, after you've started your sketch, I'm going to start going through some of the geometric shapes that you can create to start designing your part. So the first and simplest one is just a line, and that's the L key, or you can select it from the feature bar on the top of the workspace. So if I switch back over to Onshape, this up here is your feature bar. These are all sketch features that you can use, and sketch constraints. I'll get to constraints later, but these up here are all sketch features. So the first and simplest one, you got a line. You can either hit this button here to create your line, and then you click and drag to create your starting and ending points. That's one way to do it. You can also press the L key to create a line, and then click and drag to create your starting and ending points. Or the way I prefer to do it, I press L, and then you don't have to click and drag. You can also click to start, and then click for every additional point you want to add. So that'll create one or more lines, and then double click or press escape to end. So to show that, basically L to create a line, click once to start it, click again to create another point, click again, and then when I'm done creating lines, I can either press escape or double click, and that'll end my line. So yeah, that's the second way to create a line. Control Z and Control Y, by the way, just for undo and redo, just like any other Google Docs or Word or whatever you've used before. So, so that's the line. Yeah, oh, also, one important thing to note here is, in a previous line I drew, I connected it to this point here. This point, which is at the center of all of our planes, that's the origin, and you're going to use the origin a lot just to make sure that your lines and points and shapes are all constrained. So I'll talk about what constrained means in a second, but basically, yeah, you can, when you're starting your line, you can just click on the origin, and then that point will be tied to that origin. Okay. So the second tool I'm going to go over is corner rectangle. So you can see I've got an image here of how that one works. That is the G key if you like using keyboard shortcuts. I never remember that one, but I don't use it that often either. So basically you left click or drag at the first corner, and then either click again or release if you started dragging it at the opposite corner. So you can either click once at one corner, click once at another corner, or just click and then release when you're done with it. So I'll demonstrate that one. So up here, here's your corner rectangle tool right next to line. I can either click that, or I can click G. It starts my rectangle. And then I click once for point 1, click again for point 2, there's my rectangle. Or I can click and drag to create a rectangle like that. So super simple tool. Okay, next tool, we have our center rectangle. Same concept, it's again, you click to start, click to end, or click and drag, and then release. But this time, rather than starting at one corner and going to the opposite corner, the rectangle starts in the center, and then you click and drag outwards to make the rectangle. So I'll demonstrate that. Another thing is when you're making these rectangles, I believe, here, let me, okay, so that's how the quarter rectangle works. You just click once to start it, click again to end it, and it creates a rectangle like that. And that's the R key if you want to use the keyboard shortcut. Also, if you hold Alt, this is what I was going to say, if you hold Alt while creating a rectangle, it makes all the sides equal, so it makes it a square. And I think that works for the quarter rectangle and for the center rectangle, so for both of them. You can create some easy squares like that. Okay. Finally, after you finish an entity, so an entity would be like a rectangle or a line or something, after you finish your entity, you can press, you can type any value in, any number, and then press enter, and that will give your entity a dimension. So a general rule of thumb is if you're doing a rectangle, the horizontal dimensions get entered before the vertical dimensions, but basically you type one number, press enter, type the other number, press enter, and it will give it a vertical and horizontal dimension. So show you guys that. I'm going to create a corner rectangle with G. I'm going to click once, click again, and I just finished my shape. But if I start typing now, it'll start giving me a horizontal dimension. So if I want to make my horizontal dimension, let's say 2 inches, press enter. There, I've given myself a horizontal dimension, and then if I type another one, let's say I want my vertical dimension to be 1.5, I type 1.5, press enter, and now I've given it a vertical dimension. So again, just to show that again, let's say I'm creating a line this time maybe. I want to give it a length, so I click twice to make my line, and then I press escape because it's, well, actually no, I have to click and drag for this to work. So I click and drag to create my line, and then I enter, let's say 2.5. That gives the line a dimension, a length of 2.5 inches. Also, we work in inches for all of our Onshape documents, so one thing, and that's just because it's the standard in FRC, not because I think that inches are a better system than metric. I don't, but in FRC a lot of the parts we use inches, so we do too. So anyway, if you want to go into, if you click My Account and then Preferences, you can change your length units to inches and your angle units to degrees and your mass units to pounds, just because that's what we use. So that way every document you make will have those settings. But if you've already made a document and you haven't done that, you can also go into this little menu up here. This is the file menu, and then go into workspace units and change your units to inches. So I recommend you do that before going any further, because all the exercises I have are in inches as well. So moving on, now you know how to create dimensions. We're going to go over some more sketch features. So center point circle, similar to the center point rectangle, but it's a circle this time, super self-explanatory. The keyboard shortcut for that is the C key. I'll demonstrate that really quick. So I can go back into my sketch. I accidentally closed the sketch. I can either press this button up here for center point circle, right next to rectangle, or I can press C. That creates, and then I just click on the point I want to start at, and then click again to set the diameter. And again, I can like type a dimension, and it will give it a diameter. So the key dimension in these circles is diameter. The next type of circle, you can make a 3-point circle. So this defines the circle based off of 3 points on the edges. And I guess this is useful for like when you want the edge of a circle to be touching something, but you don't know the diameter, so you want it to maybe be touching 2 things. So this one I don't think has a keyboard shortcut. You have to go into this little drop down under circle and then press 3-point circle from that menu. And then you can click for 1 point, click for another point, and then click for a 3rd point, and it defines your circle. There's no dimension you can add to this off the bat because it's defined by points, not by dimensions. You can actually add dimensions later, and that's really important, but I'll get into that later in this presentation. So again, 3-point circle, from this drop down, click it, point 1, point 2, point 3, there's my circle. Okay. So a similar concept, but now we're moving away from circles and we're moving into arcs. So arcs are some of our most used tools in Onshape when creating parts. And the A key is the keyboard shortcut for the 3-point arc. So the 3-point arc, you first click to create the starting point, then click again to create the ending point, and then you click again to set the desired radius. It's really intuitive to use, but you're going to have to get used to it because we use it a lot. So demonstrating that, here's the button up here for 3-point arc next to circle, or I can just press A. I click once to start it, again to create the ending point, and then I click to set the radius. So I can set it to like something like this, and then I can actually type in my number. If I want it to have a radius of 1, now it has a radius of 1 inch. So it's pretty intuitive to use, but again, click once to start, click again to end, and click to set the radius. Right. These are some arcs that we don't really use as much, or at least I don't really use as much because they're just not as convenient. But they create the same type of arc, they're just defined in different ways. So the first one is center point arc. So this one's created kind of like a circle. So you start with the center of the circle, the center of the arc, and then you left click at the starting and ending points, which also indirectly sets the radius, but it's not defined by that radius. So I guess this would be useful. Actually, this would be pretty useful in a lot of cases. I just don't use it that often for some reason. So I click to start it, click at the starting point, click at the ending point, and there I've got my arc. And you may have noticed when I started that, it created these weird dotted lines. These are called construction geometry. I'll get into what they're for later, but basically they disappear in this case because they're not actually needed. But yeah, I can click and click, and then if I wanted to set my radius, I could set my radius afterwards. So that's another way to create arcs. And finally, last way to create arcs, tangent arc. So if you haven't taken calculus, the concept of tangency is super intuitive. You don't really need an understanding of calculus to know what it is, but in calculus you will learn how to solve for them. But anyway, the concept of a tangent arc or a tangent surface is basically if you imagine a curve and you imagine a line touching that curve, what angle would that line be at so that the slope of the curve is smoothly connected to the slope of the line. So I think it's best if I just show what that looks like, but a tangent arc basically defines the arc based on a ending point and then the endpoint of the tangent arc. So to show that, if I have a line, let's say I've already drawn a line here. I wasn't on the correct plane there. If I've already drawn a line here, right? There's my line. I can go up here to tangent arc, click once at the ending point, or at the starting point, and then click again, and it will automatically be tangent to this line. And what I mean by tangent is notice how the slope of this arc just basically equals the slope of this line. So if this line was at a different angle, say like this, and I created a tangent arc, it would do the same thing, right? So it would be equal slope at the point where they touch. If I were to extend this arc, and I was to extend this line, you can see that they're basically, at that very point where they touch, the slopes are exactly the same. So that's the concept of a tangent arc. Moving on from arcs and circles, we've got a few more different types of sketch features that you can use. So first one is polygons. So for these, there are two different types. There's an inscribed polygon and a circumscribed polygon. Those words basically just mean that either your radius or your diameter is setting the distance between parallel points or parallel edges of the polygon, or it's setting the distance between the furthest away points on the polygon. So in an inscribed polygon, if you imagine a circle on the inside of the polygon, like you can see in this example here, that circle is touching all of the parallel edges. So the top edge is parallel to the bottom edge, and those are the closest points on the polygon. So you're defining a diameter that's equal to the closest points on the polygon, whereas in a circumscribed polygon, as you can see, the circle representing the diameter is touching all of the farthest away points on the polygon. So you're setting a diameter that's equal to the distance from this point to this point. So I'll demonstrate both of those. Basically, you left-click on your center point first, and then you move the mouse and left-click again at your desired diameter, just like you're creating a circle. And you can then move the mouse up or to the right to add sides to your polygon, or down and to the left to remove sides from your polygon. And then you left-click again when you're happy with the correct number of sides. You can edit the number of sides or the diameter after the fact, so it's not really a big deal if you get it wrong when creating it. But just to demo that real quick, here's my two types of polygons. They're up here in the menu next to arcs. They don't have any keyboard shortcuts, unfortunately. But starting with an inscribed polygon, I click once at my center point, and then like I'm creating a circle, just go out and click again to set the diameter of my circle. And then if I move the mouse up, it increases the number of sides, or if I move it down, it decreases the number of sides, with the minimum obviously being 3, because you can't have a two-sided shape, and the maximum being, I don't know, infinite maybe? And same thing works if I move it to the left or to the right. So right to increase, left to decrease, or up and down works too. So I then click at my desired number of sides, in this case 6, and then I can type in my, I can edit these after the fact if I want to, just by double clicking on them, but I'll show you guys how to do that later. It's not really important. So that's a inscribed polygon, and then for comparison, okay, here's your inscribed polygon, and then here's your circumscribed polygon. So same thing, but yeah, the polygon's going to be a little bit smaller if it's the same diameter, because the diameter is defining the furthest points away from each other. So again, I click and then I can increase or decrease the number of sides. Pretty simple. Those are the polygon tools. You don't use them that often, but they're helpful when they're needed. Okay, so now we're getting into the really important stuff. The mirror key, the M key, is the keyboard shortcut for mirror. And in order to do a mirror, you have to have a mirror line, but this will basically replicate all of the features, all the sketch entities on one side of the line over to the other side of the line. And what this means is you only have to do half the work. If you're designing a part that you know is symmetrical, which a lot of the parts we design are, you can just design one half of it and then mirror it all over to the other side. So to demo that, again, the keyboard shortcut is M. So I'll create a line, first of all, and this will be my mirror line. This is what I'm going to use to mirror everything over. And then I can draw some stuff over here. I can just make like a circle, maybe an arc, maybe, you know, a polygon even. Three-sided polygon, triangle. Yeah, I could just make a bunch of random stuff over here. And now when I want to mirror it over, I can just, first of all, the tool is up here, mirror, or I can press M. Oh wait, actually M doesn't work, I don't think, for mirror. Never mind what I said about M. Don't use M. M is for cut. They changed this, I think. Anyway, there is no keyboard shortcut for mirror. You just have to press the mirror button. And then it's going to ask you to select a mirror line. So I'll select the one I created, and then I can just click on all the entities that I want mirrored over, and it will mirror them all over. And now the nice thing is too, if any of these move around or change their relationship, it'll change on both sides of the mirror line. They're literally symmetrical. And there's even a way to add symmetry after the fact. So if I have two shapes that I've already made and I want them to be symmetrical, like I have a circle here and a circle here, they're clearly not symmetrical. This tool over here on the top right, that sort of looks like two M's mirrored across a line, I can click on that one and then click on the first entity, then the second entity, then the center line, and it will make them symmetric. So now everything I do to one happens to the other as well. So this is a super useful tool. And mirroring also works in any direction, right? So if I've got something over here and I want to mirror it, I select my mirror line, select my entity, and now I've got my mirrored thing. Also, you can do things in different orders, and mirror is one of the commands where this works. It doesn't work for everything, so don't try it on everything. But with mirror, if I have my shapes that I want to mirror, and I select the shapes first, as long as they're not lines, because if they're lines it gets confused, it thinks you're selecting the mirror line. But if I select the shapes first, then press mirror, I can then click my mirror line afterwards. Also, another thing I did there is I had two shapes like this, and then I clicked and dragged to create like a bounding box that I can use to grab stuff, like a lasso basically, lasso tool. That's super helpful. There's actually two different types. If you do it in this direction, I believe it only selects edges, and if you do it in this direction, I'm not actually sure what the difference is, but one of them's blue and one of them's orange. Maybe that'll be something I cover in a later thing, but I'll have to look it up because I don't actually know the difference. Anyway, so that's the mirror tool. We use that a ton. The next tool is the project or use key, and this one is only really relevant when you have models in play. You've already modeled a part, and you want to take the dimensions from that part and add them to another part. So the example I have here in the left side of the slide, I've got this model, right, and I have this model pulled up on Onshape too, so I'll show you guys how to do this live. And then I have a sketch on top of it, and basically by highlighting that face and pressing U for use, I can project all that geometry into my sketch, and then I can use it for designing another part. So to show that, I have that exact part already open. It's like a little key. If I create a new sketch, and let's say it's on a plane that's offset from this part. So I already have a plane created that's offset from the part, right? I'm on a different plane, and I want to use all this geometry so that I can design some other stuff on top of it. I can basically just select the face and then press U, or I can press, where's the button? It's one of these. This one up here. Use. It looks like a little box. If I press that, you can now see, even if I hide the part, all the geometry's been copied over, and now I can add additional stuff on top of it, you know, and mess around with it, and modify it to suit whatever I'm trying to do, right? So this is an easy way to quickly modify parts and stuff. And it's used all the time, because also one thing that is important to keep in mind, the more geometry that you include in one sketch, first of all, the harder it is to understand your own work and go back to it and edit it over when you're trying to fix mistakes, but also the laggier it gets. So the use command is a good way to keep things separated. You can keep your key geometry in one sketch, then create your part, and then do all of your detail work in another sketch, just to keep things clean and less laggy. Last thing, construction geometry. So this isn't really a tool, this is more like a mode that you can put parts in. I mentioned this earlier with the polygons. Basically, it's just a dotted line like these ones. And the important thing about it is it's ignored when you create a feature. And I'll show you guys later what creating features is. But there are plenty of circumstances where you want a line to be there to help you draw your shape, but you don't want it to actually be a part of your part. And so in those cases you use construction geometry. So like in this example down here, right, you've got two circles, and I want them at a 45-degree angle from each other. Now there's no easy way to tell these circles to be 45 degrees from each other, other than drawing a line between them and then making that line 45 degrees from something. So the key to create a piece of construction geometry, the keyboard shortcut, is Q. I don't know why it's Q, it doesn't make much sense, but it's Q. And I'll switch over to Onshape and show you guys how to make construction geometry. Like, let's say I have a circle. If I want to turn this into construction geometry, I can either press Q or press this little button up here that looks like a line with a dotted line next to it and two arrows. So if I click that, this turns to a dotted line. You'll also notice it's no longer shaded on the center. So before it was shaded in the center of the circle, it becomes unshaded when you make it construction, and that's because it no longer is affecting features or regions within the sketch. It no longer has an impact on regions within the sketch. So another way to do this is you can put things into construction mode before you create your features or your entities, and then they will be construction entities when you create them. So if I put it into construction mode, I can start drawing whatever lines I want. They're all going to be dotted because it's, you know, in construction mode. And then as soon as I make a new entity that's not part of that last one, it'll go back to normal. So again, I can either create it as a construction line to begin with, or if it's already a construction line, or if it's already not a construction line, I can select it and turn it into one. So that's how to create construction geometry. Moving on. Oh, okay. So here's the first like practice exercise, basically. So I want, if you're watching this recording, to try and pause this video here and create a new sketch in a document. So if you haven't started a document, start a new document that you'll just use to do these little practice exercises. I don't know how long this will take if you've never done CAD before. To me, it seemed like a pretty simple exercise, but it might be more complicated than it looks. So what I'm going to do is, I recommend that you pause here, because after this, I'm going to do it myself and demonstrate how I do it. But pause it here so that you don't have the solution given to you automatically. And then after you're done, just resume it, and I'll explain how to complete this one. A few things before you start, though. Remember that if you just type a number after you create an entity, that'll give it a dimension. Remember that you can hold Alt while creating a rectangle to make it a square, and remember that you use the Q key for construction geometry. So yeah, there's a few different features on top of each other here. Try and figure out which shapes are which ones are lines, which ones are polygons, and which ones are squares, which ones are construction, and which ones aren't. So go ahead and pause now. I'll be back in like 5 seconds. Okay, if you've unpaused, I'm going to demonstrate how I would do this. So the first thing I'm going to start with is a center point rectangle. That's what I see here, is a center point rectangle. And I think I can actually split screen this, so I've got the model up here on the top left and my Onshape here on the bottom right. So I'll start with my center point rectangle. That's the R key. I want to make it construction, so I'm going to press Q. And I want it to be a perfect square, so I'm going to hold Alt. So I also know that it looks like it has a side length of 3. So after I finish it, I'm going to type 3. And now it has a side length of 3, and I've got my first construction shape. And then I'm going to, I think I see like a polygon here, 8-sided polygon, and because the diameter is being defined on the outside of the polygon, I know that this is a circumscribed polygon. So I'm going to go ahead and create a circumscribed polygon. Again, also the center point is the origin. That's very important. I keep using the origin here as my center point. And then as I drag this out, it looks like in the model, the corner of the polygon is touching the corner of the square. So I'm going to use the corner of the square as the corner of my polygon. And then I'll drag the mouse upwards to increase the number of sides to 8, because it's an 8-sided octagon, and then click again to finish the part. So now I've got my 8-sided polygon. And then there's some additional lines here drawn on top of everything, sort of making triangles. So I'll use the line tool to just draw a line from here to the bottom, and then from here to the bottom, and then do the same thing on the... I could either just draw the same thing on the top, or I could use the mirror tool. So I think I'm going to use the mirror tool. I'm going to mirror this line over to the other side. Okay, and then I'm going to select this center line here, the horizontal line, and then mirror these across the horizontal. And that'll finish my shape, sort of like a disco ball maybe looking thing. I don't know. I wasn't very creative when I created this, so yeah, one thing I forgot to mention is if you already know how to sketch, which I think a few of you do, I would have just disregarded this exercise and had you do something more interesting. So if you want to, go ahead and try and sketch something more interesting and send it to me. But yeah, hopefully you guys got to this point. Yeah, again, I don't know how difficult this will be if this is your first time doing it, but I hope I've explained things well enough that this made sense. Okay, moving on from this exercise, the next thing we're going to go over is the basics of what dimensions are and how to use them. So we've already created sort of implicit dimensions when we created a new entity, and that's one way to create dimensions, is to create them when you're creating an entity. But the other way is to create them after the fact with the dimension tool, and that's the D key if you want to use the keyboard shortcut. In fact, I would strongly recommend you use the keyboard shortcut for this one because you make dimensions a lot. So to make a dimension, you left-click your target entities before or after using the dimension tool. So you can either press dimension and then click your target entities, or just click your target entities, then press dimension. Both work. And then once you've typed your dimension, you can then press enter and it will give it a dimension. So to demo that real quick, switching back over to Onshape, if I have a line that I've just made, and I want to give it a dimension, I can either go up here to the top bar and find the dimension key. I don't even know where it is because I always just use the keyboard shortcut. This one here, dimension. It looks like 2 arrows in opposite directions. Click on that, and then I can either click on my line, which will give my overall line a dimension, like this, 2 or whatever, or I can click on 2 separate points, and it will create a dimension between points. You also might have saw here, you can also have dimensions that are aligned with certain axes, like a horizontal dimension, or a vertical dimension, or like a horizontal dimension, and that's when you're measuring between points. So that's useful for a variety of situations, right? If I want this to be 1.5 inches from the ground, right? That's helpful, I guess. Same thing works for like an arc. If I make a 3-point arc here, I can set things like the distance between these 2 points and also the radius. Also, you noticed here it turned to black. So I'll go into on the next slide why this happens. This is called a defined sketch, or it's not over-defined, it's not under-defined, it's defined. I'll explain that on the next slide. So that's how you use the dimension tool. There's a bunch of different types of dimensions you can create though. So you can specify the length of a line or an arc. You can give the diameter of a circle, the distance between points, the angle between lines. Oh, I forgot to show, yeah, also, when you are working on arcs, there's a special kind of dimension. The length of an arc, right, can be given in 2 different ways. Either just the distance between these 2 points, or if you move the mouse over so that you're close to the actual arc itself, you'll notice the arrows become curved, and that's because it's actually measuring the length of the arc along the curve. So I can say that I want the arc along the curve to be like 2.5 inches, and now if you were to go along this curve and then measure with like a curved measuring device, it would be 2.5 inches. So yeah, that's a special type of dimension that only works for arcs. So yeah, length of a line or arc, diameter of a circle, distance between points, angle between lines. I didn't show this one. So again, if I have 2 lines here, I can click the dimension tool, click on one line, then click on another line, and it'll give me this little angle thing, and then I can modify the angle up or down. And yeah, this could be like 45 degrees or whatever. So I'm switching back. So if you want to modify an existing dimension, you just double click on the little number. You can also click to select a dimension, and then if you want to delete it entirely, you can just hit delete or backspace depending on what your keyboard has. So to demonstrate that real quick. Okay, I made this dimension some weird number. If I want to change that, I double click it, see? And then I can go like 1.5 and make it something normal. And then if I want to get rid of it entirely, I hover over it, click it once, not double click, and then hit backspace or delete. And that gets rid of it. So that's how you modify or delete dimensions. Same thing works for any other type of shape. Right. So moving on. So the next section is on the constraints. So when you have a fully defined sketch, it'll turn black. When you have a over-defined sketch, it'll turn red, and when you have a sketch that's not fully defined, it'll stay blue. So you want every sketch to be blue, to be black, right? Not blue, not red, because that means that it's no longer able to be manipulated depending on how it's dragged around. So an important thing is, I haven't showed this yet, I don't think. When you create like any sketch entity, right? If you don't define it, it can just be dragged around to any length or distance or shape that you want it to be. Especially if you don't tie it to the origin. If you just like leave it out here, you can drag it in any direction, you can make it bigger, smaller, whatever. Like, it's completely undefined. Now when you add dimensions to it, it starts to become defined. So if I make this, 2 inches diameter, now I can no longer make it bigger or smaller, but I can still drag it around. But if I were to not only give it a dimension, but also tie it to the origin, now it turns black, because it can no longer be dragged around. It's also centered on the origin, and it can no longer be made bigger or smaller, so it's completely constrained, fully defined. However, you can also take things too far and try and define it in a way that doesn't make sense. Like, for example, we know as a fact that 2 does not equal 1, right? So if I make a line through the center here, and it's also through the origin, so this line is basically the diameter line. I've told this circle it has to have a diameter of 2 inches. And if I try and make the dimension of this line to be 1 inch, obviously that won't work, and it turns red, because you can't have a circle that has a diameter of 2 with a line going through the center that's 1 inch long. That won't work. So when things turn red, you've really messed up. You've done something impossible. Sometimes when your sketches get really complicated, it'll become hard to even know what you did wrong to make it turn red. So that's again another reason why you don't let your sketches get too complicated, and try and keep them separated and simplified as much as possible. So yeah, fully defined entities turn black, they can't be moved or altered, and over-defined sketches turn red, meaning there's some sort of error or conflict going on in the sketch that you have to resolve. So yeah, that's the basics of constraints, what they are and why they matter. So a lot of constraints when you create a shape are implicit to the shape. For example, in like a square, all of your sides are going to be equal, and 2 of your sides will be vertical and 2 of them will be horizontal. Your sides will be parallel and perpendicular to each other. Those are all constraints, different types of constraints. Equal, perpendicular, parallel, vertical, horizontal, and I'll get into what all of those constraints, how you apply them later. But first I'm going to start with how you view them and how you edit them. So, or how you can remove them if you want to. So, first of all, to view a constraint, if you just hover on like an entity, like a point or a line, all of the constraints will pop up in these little boxes like this. And they'll all show up where they're applied to the entity that they're applied on. And you can also hit View All Constraints, which will show you all your constraints. I don't ever use this basically, but I guess it's useful sometimes. And then you can click on them and delete them, or leave them as is if you want to, with the delete key or the backspace key. And then, so I'll just show you guys how to view constraints first. So switching back over, here let's say I make a center point rectangle, right? Now, obviously, there has to be a constraint saying that this line is perpendicular to this line, right? And there is. If I hover on the line, you'll see these little things pop up. And this one here is saying that this line is perpendicular to the line down there, to this line. And they both have this constraint applied to them. So I can then click that constraint and delete it, and now all of a sudden it's like Jello. It's no longer perpendicular to anything. Whereas before it was all locked in place, right? It was perpendicular. So that's how you view and delete constraints. Also, a lot of these constraints will happen automatically when you start moving things around to different locations. So while sketching, it'll automatically suggest certain constraints. And this is indicated by like a dashed yellow line, like the one you can see here. So you can hold the Shift key to basically ignore these. This is sort of like if you've ever used like a drawing software or something, and it has like a snap to grid feature or snap to something. This is like a snap thing. It snaps your parts to a specific constraint, usually horizontal or vertical. Yeah, you can hold Shift to repress them. So to show this, you might have accidentally done this already. It happens pretty often. Let's say I want to make a circle, right? And I'm trying to select my center point, and I just happen to drag it over the origin. You can see this dotted line pops up between the origin and the cursor, and that is a vertical constraint that's being auto-applied. So if I were to create this circle now, it's now constrained with this little vertical constraint. It's forcing the center of the circle to be on the vertical axis relative to the origin. I can't move it side to side. The same thing happens with like if I have a line or something and I create another line, often it will create this auto interference between 2 points, right? Where it wants them to be vertical from each other or horizontal to each other. And if you don't want these, if you want to ignore them in a specific circumstance, like let's say I'm trying to create something and I don't want it to be vertical to the origin, I can just hold Shift, and then all of a sudden the thing goes away. So that's kind of useful. So that's auto interferences. You often don't notice them, but sometimes they become annoying because they apply themselves where you don't want them to. So the specific constraints, I was mentioning a few of these offhand just a second ago, but the most important one and the one that gets used a lot is coincident. This is basically, it's a constraint that forces 2 points to be touching, and the keyboard shortcut is the I key. So this constrains 2 points to the exact same position. As you can see in this example here, we've got 2 points. I've selected them, I've pressed the constraint key, the I key, coincident, and it's brought them together, made them touching. So also you can either press the key before you press your entities, or you can press your entities, then press the key. It doesn't really matter what order you do it in when you're applying constraints. So to demonstrate that, here, okay, I've got 2 lines. And I want these 2 points to be touching. I can either click the coincident button, which is right here, or I can press I, it's the keyboard shortcut, I, and then I can hit my 2 points, and now they're touching. And they'll always stay touching. They're constrained to be touching. You can also make something coincident to the origin. Press I. Now it's coincident to the origin and to this point. And this is super useful for just creating all types of shapes. You know, I can make this coincident to that, I can make this coincident to that, make it a right angle, you know, all sorts of different things. And it's another one of those things that gets auto-suggested a lot. So, yeah. Moving on, another type of constraint, vertical and horizontal. The H key and the V key, very straightforward. It can be applied in 2 ways. First of all, you can make lines vertical or horizontal, or you can make points vertical or horizontal relative to each other. So I'll demonstrate both of those real quick. First of all, I've got two lines. I want this one horizontal. Press H or select the horizontal button from up here. I don't even know where it is. This one here. It looks like a horizontal line. We can make this one vertical. And now they're constrained to be vertical. They can't ever change angle. This one's constrained to be vertical. This one's constrained to be horizontal. Same thing works for points. So if I have two circles and I want one to be above the other, I can select their center points and then hit the vertical constraint. And now they're locked. One is locked above the other, right? They're locked vertical to each other. So that's like a relative vertical. Next one, equal key. That's the E key. This constrains lines to be equal length and circles and arcs to have equal radius. I'll show that. It's really self-explanatory. I've got two lines here. I want them to have the same length. So I press E. Now they have the same length. They're exactly the same length. Right? So like if I wanted to make an equilateral triangle, I could draw three lines. And then I just click on all three of the sides, press E. Now it's an equilateral triangle. That's equal. Same thing works for arcs. But for arcs, it's not the length of the arc. This is important. It is the radius of the arc. So if I make these two arcs equal, they're not going to be equal length. I can still change the length, but they will be equal radius. So as you can see, they're basically like the same arc radius. Same thing for circles, but again, it's diameter, not circumference. So I can make these two circles equal. They'll have the same diameter. So if I make one smaller, the other one gets smaller. Make one bigger, the other one gets bigger. Super self-explanatory. Okay, last one, concentric. Actually, there's a few more after this, but concentric. This makes circles and arcs share a center point, and it can also make a point coincident to the center of a circle or arc. So to show that with a circle, if I've got two circles, I want one to be inside the other, to share the same center point. I can click this button up here for concentric. I don't think there's a keyboard shortcut for this. And then I click on my two circles, and one goes inside the other. Same thing if you want a circle to be concentric to the center of a point. So let's say I want this circle concentric to the origin. I press concentric, press the circle, press the origin, and then boom, I've got a circle concentric to the origin. Same thing for arcs. Got two arcs here. I want them to share a center point. I can press concentric, and now one is kind of like inside the other, as you can see, right? They're like, they share the same center point here. And same thing if you want an arc concentric to the origin, you can make it concentric to another point. So last few constraints. These are some of the more common ones to use. So first of all, perpendicular and parallel do what they say on the can. They're very simple. It creates a right angle between two lines, or makes two lines, be parallel, have the same direction. And the perpendicular doesn't have a keyboard shortcut, unfortunately, but parallel can be. You can save yourself some time by pressing B. The B key is the keyboard shortcut. So to show both of those off, for parallel, let's say I've got two lines. Press B or select this. Where's the icon? This icon up here. Looks like two parallel lines. Don't get it confused with the equal icon up here. Now they're parallel. Perpendicular, same thing. Got a line, and I've got another line. I want them to be perpendicular. Press that. This will get auto-suggested too. If I've got a line and I'm creating another line, it'll auto-suggest that they're perpendicular. So that's helpful. Tangent and normal are the same thing, but rather than a line and a line, it's a curve and a line. So these examples sort of show tangency in a better way than maybe I explained it. You've got a line and a curve, and now they're tangent. Basically, it's the same thing as like parallel, where the line is, it has the same slope as the curve it's touching. It's the same thing for normal, except normal is perpendicular to tangent. So to show that off, I'll do what I showed in the picture there. If I've got a line, I can make it tangent like that, right? It got auto-suggested there, but I can also use the constraint up here, tangent, press T. T is the shortcut for tangent. And then click on the line in the circle. Now they're tangent. You can see this one sort of lags a little bit, but and then normal is the same thing, but perpendicular to tangent. So if I make this normal to the curve, normal is this little icon here, and I think the button is N. No, it's not. It has a shortcut though. No, it's not N. Okay, it's not a thing. There is no shortcut, sorry. If I press normal here, as you can see, this is now normal to the curve. It's perpendicular to the tangent. So if I were to draw a tangent line here, it would be perpendicular to the normal line. I promise we'll get out of the geometry stuff soon. It's kind of a bit boring, but it's very essential to understand the rest of it. So finally, midpoint. It constrains a point to the middle of a line or arc. So very self-explanatory. I've got a line. I want another line to be in the middle of it. Click on the point. Click midpoint. Click on the line. It's now directly in the middle of the line. Same thing works for arcs. If I've got an arc and I want a point in the middle of the arc, there's also a little point button up here if you want to just create a point without the line. You can put that point on the arc, press midpoint, click on the arc, and click on the point, and it'll make it exactly in the center of the arc. Finally, this is the last exercise of the sketching section, I believe. So I think I'm going to leave this one as like an assignment to do for next week, or at least we'll review it next week, and I'll do it live then, hopefully, if we do have a live meeting next week. But I guess I can do a demonstration here of how I sketched this bowl-shaped head thing. Again, it's just our logo. I'm not that creative when it comes to art pieces like this. But to demonstrate how I do this, I'm gonna switch it to the split screen view. So there's a bunch of different constraints and dimensions going on here. So the first thing I see is that this arc up here, based on this little dotted circle, I can tell that this arc up here that's forming the top of the head is concentric to the origin. So I'm going to draw an arc concentric to the origin. Also, an important thing is this whole piece is symmetric, so I only need to sketch half of it, and then I can mirror it all over. So also the corner points of this arc right now are completely undefined. I'm not going to worry about that. But what I do know is that they are 3 inches apart from each other in the horizontal axis. So I'm going to make that 3 inches apart, because that's what it says here on the graph. Now I'm going to start on the horn. Again, just another arc. So A key to create an arc. I'll drag my arc down until it looks about the right radius, and now I have to start applying some constraints. So this is a smooth surface. I need these 2 arcs to be tangent to each other. So I'm going to press T for tangent, click on arc 1, click on arc 2. Now they're tangent. And one thing that's sort of bugging me here is that these 2 points are supposed to be horizontal to each other. So I'm going to apply the horizontal constraint, make them horizontal to each other. Next thing I think I can do, the tip of the horn here looks like another arc. It's sort of rounded. So I'll go ahead and sketch that arc. And then there's another arc going down the bottom for the bottom of the horn. And I'll go ahead and sketch that one too with another 3-point arc, the A key. And none of this is constrained, right? If I drag this around, it all breaks. So to fix that, I have to start applying some tangent constraints, because everything is smooth with each other. They're all tangent to each other. So I'm going to press T for tangent and make this tangent to that. And then I'm going to make this tangent to that. And it looks a little out of proportion, but that's fine. So I can sort of drag it around until it looks about right. Also, this arc here seems to be tangent to the horizontal plane. So I'll go ahead and press the tangent button, make this arc tangent to the horizontal plane. And it also appears to be on the same circle. The end of it appears to be on the same circle as this arc here. So given that I know that, I can create a construction circle with the same diameter as the big one, as the top of the head here, and make this coincident, using the coincident button, with that circle. That's one way to do it. I could have also just made this point coincident to this arc, because technically the arc continues here. It's on the same circle, right? So I could do it that way. Again, nothing's really defined yet, but I do know the radiuses of these arcs. I know that this one has a radius of 2 inches, the bottom one has a radius of 3 inches, and the top corner, the tip of the horn, has a radius of 0.25 inches. That's a quarter of an inch. So 0.25 up here, 2 inches here, and 3 inches for the bottom one. Okay. There's also one dimension that I think I'm missing from the original graph. I should have probably included this, but that's the radius of the top of the head here. I'll define that though in a second. So moving on, I can do the bottom of the bull's face. I've just drawn a line here with the L key, and then I pressed A for arc, for 3-point arc, and made a 3-point arc for the bottom of the bull's snout, I guess. And again, just like I did on the top one here, I need these 2 points to be horizontal from each other so that this will be like perfectly mirrored. So I'm going to go ahead and do that, make these 2 points horizontal. Or sorry, I made them vertical, oops. Horizontal, H. And then also, I need the snout to be like centered on the origin, so I'm going to go ahead and make it vertically offset. So I'm going to use the vertical tool, click the origin, and click the center point of the arc, and now it's centered on the origin. I also know that the radius of this bottom arc is 1 inch, so I'll define that. And finally, the dimension that I was talking about that I think I'm missing here is the radius of the top of the head. I think this is going to be necessary in order to constrain everything, so I don't know what it is, but I'm just going to go ahead and leave something here to define it. Also, there's one more dimension I'm missing, and that is, it's 5 inches apparently, if you look at the, from the corner of this arc to the corner of this arc. So that means that the overall radius of this circle, oh, I guess I'm not missing a dimension. The overall radius of this circle, I mean, must be 2.5. I guess what I could do is I could just mirror everything over and then add the dimension as it's given in the drawing. So I'm going to select all my points, or all my lines here. Or actually, that's bad practice. I'll press the mirror key first. So I'll press the mirror button up here, select my center line, and I'll select this center line of the whole sketch, the the vertical plane. And then I will select all the components that I want to mirror over. So this line, this arc, and this arc. And it's starting to look a little bit like what I was going for now. So final thing, I have to add a dimension between this point and this point, which in the original drawing is given as 5 inches. So I'm going to go ahead and add that. And I think it's almost constrained. What am I missing? Oh, I'm missing a few things actually. So the first one is the overall distance between these two horns is 11 inches as given here. So I'm going to click on both those arcs, set it to 11 inches. And also the distance from the top of the head here to the bottom of the head is 6 inches. So I'll set that as well. So when you click on two arcs like this, it'll create the dimension for the furthest point between them. So you see with that last dimension, it all turns black. That means it's all constrained. And that is the finished example. So hopefully you did this without the instructions, but if you needed to refer to this for a little bit of help, that's fine too. I'm going to go ahead and wrap it up here. If you watched all the way through, good for you. Thank you. And yeah, hopefully we can schedule something for next week, or do another asynchronous recording if need be. All right, bye.